Hello and welcome everyone to our next live stream. Today we're going to be talking to Stefan Kremser, and he's going to be explaining some of the updates to the Deauther, and we're going to go through actually trying some of them out and seeing how they work, and probably doing a little bit of bug fixing along the way. So Stefan, thank you for joining us, and can you tell us a little about the Deauther for people who might not have heard of it? Although at this point, since you've been on the podcast and we've also covered it a couple times, that's probably pretty unlikely.
Hello. The Deauther is a project I've been working on for quite a while now. It basically is a piece of software made for the ESP8266, which is a little cheap microcontroller that has Wi-Fi integrated in it. So it's basically a little Wi-Fi card that you can program. Sorry. And my software basically makes it a little easy to use hacking tool. So you don't need fancy, like a Linux hacker distribution and special hardware and drivers for it. But you just need that like $3 microcontroller that you can easily program yourself and can do some like cheap, easy Wi-Fi hacks and learn more about Wi-Fi hacking.
So also for anyone who thinks that this might be like an exotic piece of technology, like it is everywhere. Like most devices that use cheap Wi-Fi, like Wi-Fi connected lights or Wi-Fi connected power switches, a lot of things will use the ESP8266 chip because it's so easy and so cheap to integrate into products. So it's really cool that you've managed to do this with such a low cost piece of hardware. Because before this, kind of the reference for cheap hardware hacking was the Raspberry Pi, which is a full Linux computer, and frankly is pretty overkill for a lot of the stuff that's really low level and basic, that's really cool and kind of teaches about how Wi-Fi hacking works. So to be able to control something as low level as, a $1 microcontroller that you can get, mass ordered from AliExpress or from China, it's super cool because anybody who understands Arduino programming, which is designed for people who might be a little bit averse to learning C++ or something more technical, anybody can learn to work with this to create Wi-Fi connected devices or even get started with hacking projects, which is what you did after a lot of effort.
Yeah, the great thing is this doesn't have as much overhead as something like a Raspberry Pi. You don't need a lot of external components to get the Pi running. You don't need to install a lot of programs or anything. You can just download sketches from the internet, flash it to the device, and have fun.
So also, most people will be familiar with maybe development boards like the D1 Mini or the Node MCU. These are probably the most popular platforms for anyone who's looking to get started with working with the ESP8266 community, because these development boards have USB adapters. They make it super, super easy for you to just plug this into your computer and get started working on it. It's really cool to see all the stuff that's possible. When I got my first one, I was immediately trying to make anything I could connected to the internet, like work with sensors or like otherwise just try to push it as far as I could go. But honestly, it wasn't until I learned that it could be used for security work that I really fell in love with the platform and started just being amazed by what it could do.
Yeah, it requires some hacking around to make it work for some of the features we will be looking at today. But once you're in that little niche and know how to make use of these functions, then you can have a lot of fun with Wi-Fi security stuff on this chip. Yeah.
So today we're going to go over some of the upgrades to the Deauther. But before we do that, can you tell me, the Deauther project has really evolved, where originally, it was something that was kind of, you could plug it in, it generated a hotspot, you join the hotspot, and then you get access to this beautiful dashboard that lets you do a lot of stuff very powerfully from a web interface that's completely hosted on this tiny microcontroller. So for anybody that's just, wants to go in and see if this stuff really works, they can very quickly just get set up and see that this is having an impact on their Wi-Fi network. The second that they press the button, they can start scanning. Like, this is originally a really interesting, really cool tool, but it's also kind of evolved from that to also incorporate a command line interface, which I've done several workshops on, that really allows people to treat this almost like a wireless network adapter and get it to do different behaviors that are useful for a security person. Could you walk through maybe some of the main functionalities you've built into the Deauther besides just deauthing, which of course we'll get into?
Oh, yeah. There's a lot in the command line interface.
So this is also probably the best place to go if you have questions, because there's lots of documentation, including some really great interactive documentation that's been made for this project.
Oh yeah, there's this little website. Does it still work? Deauther.me. Everything is super slow right now because I'm recording, sharing the screen and everything. It's super useful because if you have the Deauther set up and you're connected to its access point and you go to deauther.me, then the web interface should appear, the web interface where you can, do all the Wi-Fi hacking stuff. But if you did something wrong, you're not connected to the ESP, then this online interactive tutorial comes up that shows you how to install it properly.
That's cool. So either way, it's useful. You're either connected to the interface itself or a guide telling you how to get set up.
Exactly.
Yeah, looks like maybe a little slow right now, but there's a lot of traffic.
So the main feature is, deauthing, right? So you can scan for networks and basically select your targets and then start a continuous deauthentication attack. That basically means you send out packets telling the devices that, hey, I want to disconnect. And since these packets are not protected in any way or certified or anything like that, every device that gets such a packet that comes from a MAC address it believes has a connection to, it's gonna close that connection, even though the packet doesn't actually come from the device because you're faking that packet.
So to be clear, this is you're basically spoofing a packet, and in the return field, you're forging maybe the MAC address of the router so that the device that receives it thinks it's getting a legitimate request from the router saying, hey, I need you to disconnect from the network.
Yeah, so that's the main feature. You're sending out these packets all the time. So that way your target disconnects, but it doesn't just disconnect once and then reconnects. It keeps getting disconnected. So even if it tries to reconnect, you are, instantly, because you're sending packets constantly, it instantly gets disconnected again. And therefore, you're basically essentially jamming that connection.
And I can tell that you hate saying that, but can you tell me why a lot of people have misinterpreted this project as a jammer?
Yeah, the thing is, in the early days, a lot of people on YouTube, they liked just, the headline, like Wi-Fi jammer, $2 Wi-Fi jammer, that kind of stuff. The problem with that is they just called it a Wi-Fi jammer and didn't really explain how this attack works, or the project, or anything around it. They just basically showed you how to create it and called it a Wi-Fi jammer without any more context. And that's problematic because if you say Wi-Fi jammer, people, that don't have this insight of all this Wi-Fi hacking stuff, they will think it's basically a signal jammer, something that creates a lot of noise on a specific frequency and therefore blocking that frequency for anything. But this is not what...
And that's super illegal, right?
Yes, that's super illegal. And that's not what we are doing here. We are using the Wi-Fi... basically, we are exploiting the Wi-Fi protocol. And we are not jamming any other connections. We are just basically disrupting a target you selected. And if you selected something, you shouldn't be targeting, I don't know, like a hospital Wi-Fi network, then you're a very bad person. But that doesn't mean you can't be using this tool to, use for pen testing or test your own networks, stuff like this, or to learn. Yeah, but...
Oh yeah, the big difference I'm seeing is it's impossible to legally use a signal jammer. As soon as you turn it on, it's blocking an entire frequency for everyone. But conversely, it's totally legal and safe to use this because it's possible to select only a single Wi-Fi network, attack it only, and leave everything else in the area completely untouched. So while it would be totally irresponsible to just turn on a signal jammer in a populated area, if you're using the Wi-Fi deauthor properly, you could only be attacking one device on one network that you totally have permission to test and actually learn about how this stuff works legally.
Yeah, so the software is designed to be working that way. So you scan, and then you select your target, your network, whatever you want to test, and then then you're responsible. You're responsible of attacking that network. If that's not your network, then you're responsible. The problem with signal jammers is you just turn them on. You don't select anything. You just turn them on, and an entire frequency band is gonna get jammed, and you could jam things that are really important, like, I don't know, emergency signals, stuff like that. You have no idea what you're jamming. That's why those are so dangerous and highly illegal. Meanwhile, this is, again, you're just selecting a specific connection, and yeah.
So if you want to be a huge nerd about it, there's actually a really great paper by one of our other guests that we've had on, which is Matthew Van Hoff, about different types of jamming in electronic warfare. And technically what we're doing is called protocol-based signal jamming. Oh, protocol-based jamming, which means we're abusing a protocol and we're not trying to take over the signal. We're not trying to like scramble anything. We're not even really like doing anything that's unexpected. We're actually sending legitimate packets that adhere to the protocol, and that's causing an unexpected and undesired behavior on the network. But it's not really, it's a flaw in the communications protocol that we're abusing. We're not actually doing jamming in the traditional sense of the word.
Yeah. And it's not a flaw that, exists in a specific implementation. It basically exists on all implementations because it's in the protocol itself, this bug. Because these deauthentication packets that basically, they are just there to safely disconnect you. Like if you join a different Wi-Fi network while you're already connected to one, then, your device would usually send out these packets basically announcing to the router like, hey, I'm leaving, bye. And you're just... you're faking these packets, making the device thinks it should disconnect, and then, yeah. You're not creating weird packets that exploit vulnerabilities in specific chipsets. This stuff also exists. We are just, we are using packets that exist in the protocol. We're not,
Yeah, so I could talk about this stuff all day. And I would also say that if you are curious learning about more of this stuff, like what makes this vulnerable, how it's being fixed, and how even the next generation of Wi-Fi is still going to be vulnerable to sorts of things like this, you should definitely check out the Security Tools podcast episode with Matthew Van Hoff, because we talked for almost an hour about the various ways you can abuse Wi-Fi, and a lot of the stuff that we're talking about can really be taken to the next level, provided you have the motivation to, and you want to really get into manipulating protocols and working with the flaws in Wi-Fi. It's super cool.
So yeah, that's the main feature. That's the big headline. That's why it's called Deauther. That's the first thing I implemented. A few other things that are quite fun about this is you can send so-called beacon frames. Those are packets your Wi-Fi router would usually send out every so often. I think the standard is 10 packets per second. Basically announcing that it's there, that there is a network there, telling everyone around, this is the network name, this is my MAC address, this is the encryption and all that details. So that when you go into the Wi-Fi menu of your phone, then you would see all the networks around because these packets exist. These are sent continuously. What I did is make a feature. What I did is I added a feature to the Deauther where you can basically type whatever network names you want to be advertised. And then the Deauther would send these packets, and a lot of them. So that way you can basically make networks appear to be there, even though they are not actually there. Because you're only sending the advertisement frames. And Wi-Fi devices scanning for those would, list them as a Wi-Fi network nearby. Even though you're not actually having those networks set up.
This is super cool for 2 reasons. Well, 3 reasons. One of them is you can socially engineer people because you can create literally any Wi-Fi network that you want, and you can create up to, 1,000 of them simultaneously. So if you want to do some social engineering, that's really, really cool. Another reason why it's awesome is you can also basically trick people's phones into behaving as though they are near a real device or a real network that they recognize. So if you create a bunch of fake networks that match the names of really common Wi-Fi networks, you can get people's phones to unmask themselves and stop using fake MAC addresses, so you can start tracking them. And you can even get them to try to join these networks, although it doesn't actually work. And then the last thing I think is cool is just how scalable this is, because you're not actually creating the full, the full network. You're able to create, as I said, 1,000 of them or so with this really tiny device. And that's pretty incredible, just because being able to create 1,000 networks is usually something that takes, a Wi-Fi network adapter, and usually it'll actually attempt to create those networks or like create a facsimile of them that takes up a fair amount of processing power. So the fact that you're able to, make so many fake networks with this method on such a cheap device and be able to have all the Wi-Fi devices in range react to them is super, super cool. I don't think people have really dug into this feature as much as it deserves. So that's why you and I have like worked extensively on kind of expanding this and looking at what's possible with this feature, because along with Matthew Van Hoff, we've had some really interesting ideas in how the ability to flexibly and cheaply create hundreds of fake Wi-Fi networks can really do a lot of cool stuff, like revealing groups of people that might work at a certain place, or just generally unmasking devices that are trying to be stealthy but have a lot of vulnerabilities in the way that they try to go about doing that.
Basically, you can use this combined with another feature I'm working on to, what you already said, unmasking and kind of tracking people, because they will try to connect to those. And right now in the current version, it's not possible to see who is trying to connect. But that's what I'm working on in the new version, for example, is that you will be able to see at least the MAC addresses of devices that attempted to join those networks that don't exist. But you can also sniff for probe requests, which are basically inverted beacon frames. So beacons, they are sent out to advertise a network that's there. Probe requests are packets a client device, like your phone, for example, would send out occasionally to ask if a certain device, a certain network it knows, is in range. And that's super interesting because a lot of devices are still leaking all your network list. So if you ever connected to, I don't know, Starbucks Wi-Fi, right, then it's in your network list, saved. Because you were once connected to it, your device now asks all the time, hey, is this network nearby? And if you can get these packets, then you know this MAC address, this device was connected to that network. And then you can, because it's not just that network, but probably a bunch of networks that your device is leaking, you can kind of create profiles on people. And it's kind of scary.
Yeah, especially if you get the same MAC address trying to connect to multiple different networks, you can learn a lot about, maybe where someone's been, where they work, where they have permission to be. I remember I was even able to see, probe frames that were looking for like a Best Western hotel that was specifically near the Grand Canyon. It was like, okay, well, I know that somebody just took a trip to Arizona. And just that little piece of information would be enough to, really freak someone out if I was just like, oh, so how was your trip to Arizona? They'd be like, how did you know that? It's like, oh, your cell phone leaked the data. It's like, most people don't know that that's something that could actually happen.
Yeah, so basically what I'm working on right now on the new version is improving on features like this to improve the scanning functionality and just like trying to get more data out of the Wi-Fi around you. And that's why I'm focusing more on the command line interface. But before we go in those details, maybe we should try setting that up.
Yeah, let's do it. So I have a D1 Mini that I have plugged into, and I'm using a MacBook Pro. And yeah, I have Arduino IDE. I think I'm all ready to go. So I'll go ahead and keep screen sharing, and I'm recording on my end as well. So I'll just go ahead and switch over to my Arduino IDE, and I can, well, that's not the right sketch, but I can follow your instructions, and if I get hung up, then you can guide me.
Okay, so the thing is, this is still work in progress, this version, but it's already public. On my GitHub, on github.com/spacehuhn/ESP8266 Deauther, you can click on branches, and you will see a v3 branch, right? And if you go there, oh my god, my computer's so slow. That's the code you want to have. So if you can go clone or download zip, it should download. All right, let me actually just do that to see if it actually works. Okay, save file.
All right, I see the v3 branch. Cool. I see the v3 branch. So if I want to follow along with this, I should just go ahead and clone and download it.
Yep, and then download zip, or you can, clone it over your Git terminal. Doesn't matter.
Yeah, I'll just do that.
As long as
we're gonna do
somehow download that branch, because that code is different from the one you see on the main page, the master branch.
Cool. All right, so I'm downloading.
Oh yeah, it works.
ESP Deauther. Wait. All right, so I'm gonna CD into the ESP8266 Deauther. ls, and then I just see, let's see, code of conduct, configs, ESP8266 Deauther. So I'll CD into, I guess, just the same directory again.
Yep.
ls, and I see all kinds of stuff, but no v3, but that's okay. I still see the INO file. So the INO file is what I want in order to...
The thing is, I'm not sure if you're on the right branch now. You cloned it over the terminal?
Yep.
Yeah, you're probably on the master branch. I don't know the git terminal commands out of my head. I'm sorry, I'm a noob.
It's okay. I'm just going to download the zip. All right, so I'm going to open the zip file, and then this is much easier. I'll just go ahead and open the INO file.
Okay.
And close the old one. Great. Okay. So, wow, this looks much cleaner. Let me go back to your screen. But this one, this version doesn't look as cluttered as the other ones.
The INO file, it's very empty, right?
Yeah, it is.
Great. Then you're having the right version. That's great. I have done a lot of cleaning up. However, there are a bunch of files, so it's not like that code went away. It's just outsourced.
Cool. So I noticed there's way more .h files and way more .cpp files, but I'm guessing that's because this is more optimized and you've broken these out into modules, or?
Yes, exactly.
Yeah. Cool. Okay. So walk me through getting started on this. Although I'll probably have most of the stuff already installed.
Okay, so on the GitHub page, let's go to the wiki. So in the top, you can click on the wiki tab, and there's basically everything explained. So there's this point installation, compiling using Arduino IDE. So we want to click that.
Got it. Oh my God, this documentation is so clean. I love it. First, we need to have Arduino IDE. Then we need to have these two sources added to our additional board manager URL. So Arduino preferences, additional board manager URL. I feel like I've almost definitely already added these, but I can just double check. Yep, this one is a duplicate, so that one's already there. And then the second one is this one right here. And it says ARM specific package. What is that for?
If you're compiling on a Raspberry Pi.
Got it. I am not doing that. And this is also a repeat. I have the same one here. So it looks like I had already everything I needed, but if you are following along, then you should have everything you need too. All right, so we add those. We then go to our board manager and make sure that we have these two installed. I'll double check mine. I notice on macOS in particular, it takes an insane amount of time to access your tools tab in Arduino IDE. Not an issue on Linux, but...
One little disclaimer for the viewers/listeners. The setup process might change as soon as version 3 is released, because I will be trying to simplify the installation process a bit. I guess it will still be very similar, but maybe the links change or whatever. So, go to the wiki page, look it up yourself, because it might change in the future.
Cool. So we need to install the Arduino ESP8266 Deauther.
Yep.
And then also the ESP8266 by community. I also have your Wi-Fi duck project in here, but we're not doing that one today. All right. So those are installed, and then I'm going to close it. And then when I go to tools, when it eventually opens, I should be able to see the ESP8266 baseboards, and mine is a D1 Mini, so I'll be selecting that from under the ones by Travis, right?
Yep. ESP8266 Deauther modules should be the headline of this section. The first thing you will see in that section is D-Stack by Travis Lin, but then also, WeMOS D1 Mini. And just select whatever you have. If there are a bunch of boards you could have that are maybe not listed in here, but for most of them, Node MCU also works.
Cool. And then I think it's detected by default, but the upload speed is 1150-200.
Yeah, you can set that higher if you want to, 921,600. That's what I have it set to. However, sometimes that fails. So depends on, your computer and stuff. So 1150-200 is the safe option.
Okay. And then CPU frequency, 160 megahertz versus 80 megahertz. It's set to 160.
Yeah. It doesn't really matter that much, but, if you want to have extra speed, why not just take it?
The flash size is set to 1 megabyte, 256K spiffs. Is that accurate for just the generic D1 Mini?
That's, I think, that's a good option. 1 megabyte, 256 spiffs should work for basically all ESP-based boards. Depending on the VMOS D1 Mini you have, it could have 4 megabytes. But
that's what I thought.
But, just select 1 megabyte. It's not going to give you an advantage anyway.
Yeah. Okay, good. All right. Flash frequency set to 80 megahertz. Mm-hmm. Cool. And the port gives me the option. I noticed on a on a Mac OS computer, it comes up as two different serial interfaces. One of them is /dev/cu USB serial whatever, and then the other is /dev/cu.w/ch USB serial, and then some number. It's always the second one that has a W that you're actually able to interact with or write to. So that's the one I'm going to select on mine.
Interesting.
So, all right, I think I have everything that is now required. Should I go ahead and try flashing it?
Yep.
Okay, cool. I might have some old libraries. I haven't updated that. So one other thing you might want to check if you're having errors is to make sure your libraries are updated as well, because this depends on a bunch of stuff. But throwing caution to the wind, let's see if it crashes.
I expect some error now, just because I haven't really been testing this.
Class command has no member named set description. So before I start complaining about your code, I'm going to go into the libraries. So I'll go into include library, then manage libraries. And I'm just going to update all the stuff that it says I need to update.
This is exactly what I expected. You need to update the simple CLI library. I think that's the only library you will need to update, or at least I hope so.
Let's see. Man, there's a lot of stuff I need to update. All right. I'm going to wait for this to update my list of installed libraries. Man, every time I open my Arduino, it complains so much about things that it can't find.
Okay.
All right, here we go.
I have the simple CLI library 1.0.8 installed. That should be the latest version.
I'm going to update it. Updating list of installed libraries. I think it's slowly finishing. And then I'll try this again. Anything else you think I should try to update? It does seem to take some time, so maybe I'll just skip this and try again once it's done, rather than try to install everything that needs to be updated.
I can't think of any other library I'm using currently.
I'm going to check it this time before I upload it. So while it's compiling, what are some of the other... I know that we also mentioned kind of when we were talking... Oh, it compiled. But the shift from actually having it be more of a graphic user interface with a web interface to more of a command line interface, is that something you're kind of committing to in this update?
Yes. So the thing is, I started with the web interface on the first version, and I focused on that because the goal was to create this kind of proof of concept project that shows people how easy it is to how cheap and easy it is to get a device that could disrupt any Wi-Fi connection, basically. And the web interface just seemed the most convenient to use. Plug and play, just connect to it with whatever device. You can start using it. I don't need to think of some display interface and that kind of stuff, because that's also kind of complicated to program. But the disadvantage of that is... Yeah, sorry, go on.
It looks like it worked.
You have it flashed?
Yeah.
Great. Okay, let me just finish this. The disadvantage of the web interface is you can only do so much because it's opening an access point. You basically have the Wi-Fi that's on this microcontroller. Or it's already busy. You cannot sniff or send as many packets as if you would shut down that access point and just focus on whatever attack you're trying to run. So a lot of scanning can only be done when the access point is shut down. So you cannot use a web interface for that unless you would have a second ESP, but then it gets really complicating. It would kind of destroy the simplicity of this project. So that's why I'm trying to focus on the command line interface that you can access over serial, because all of those cheap ESP-based boards you can get have a USB connection, and you can just connect to the serial connection it gives you over USB and basically use it like a terminal.
So one of the big trade-offs then for using a graphic user interface that you have to use the only, really like wireless interface the ESP has, that being Wi-Fi, is that every time you're using it, you also can't be using the primary features of the chip, which is to be able to scan and send packets. And then on top of that, your computer, after a certain period of time, will detect that the Wi-Fi network is gone or it's not transmitting anymore and will automatically switch away. So if you do like a really long scan and your computer is next to another network that it has connected to before, I've found very often my computer will just disconnect from the Deauther's control network because it's like, oh, it died, it's gone. And then I won't get the results back from my scan because it'll disconnect itself unless I explicitly tell it not to connect to other networks nearby. So there's all sorts of kind of trade-offs you get when you're using the Wi-Fi interface also for communication. So I can definitely see why having a dedicated way of controlling this device is much more useful for people that want to be able to use it flexibly.
Oh yeah, the command line interface is much more powerful just because of that. But it's also not as convenient and easy to use for beginners. So that's why I will try to implement the web interface again to this version, to the version 3.0. Currently, it's not implemented because I'm focusing on the Simple CLI and Simple CLI is the library, but the command line interface, I'm trying to focus on that and push it as far as I can, and then I will see what features of the command line interface can also be put into the web interface. But yeah,
Ooh, okay, cool.
We'll see about that.
So if I wanted to, now that I flashed this, the fastest way to get started is probably just to press Command-Shift-M, right? And just open a terminal monitor or a serial monitor.
Yeah. I mean, you can also, in Arduino, go to Tools, Serial Monitor, and just open another window.
All right, and then we get a little banner, version 3.0. This is a tool. It's neither good nor bad. It's used to study and test. Use it to create, never use it to create harm or damage. This continuation of the project counts on you. Aw. All right, so then it says type help to see all commands, type start to go through the functionalities step by step. Wow, you've really improved this. I'm gonna type help. And then, enter. That's important.
Oh yeah, this whole annoying thing that you have to type something and then wait, and then it's sent automatically. I tried to remove that. Does it work for you?
The baud rate's working. No, it doesn't. Let's see.
It doesn't. If you press enter, it should.
Whoa! You've pressed send, but nothing was sent.
Oh, are you using the Arduino serial monitor?
Yes.
Okay, in the bottom, you can select the baud rate, and left of that is a little drop-down menu where you can select the line ending. I guess for you it says no line ending.
That's right.
Yeah, select whatever else. Just select some of the others. New line, for example, or both NL and CR. I'm not sure if carriage. Let me try if carriage return works.
Whoa. Yeah, as soon as I did that, I sent the command, help, 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 chicken help. Because I wanted to I wanted to see if it would drop the chicken banner still, which I'm going to try now.
I don't think so.
Before we go any further. You didn't implement it?
No, I'm sorry.
Wait,
I'm going to write that down now.
Command not found at chicken. Okay, good.
Chicken.
See, we're bug fixing already.
Commands. I'm writing it down. Okay. Okay, so I just tried. You have to select new line or both NL and CR. Carriage return doesn't work and no line ending doesn't work. The reason why that is basically when you send something, at the end of that string you're sending, there will be some kind of line ending, like a line break or a carriage return, or both. That's what you're selecting there. And the ESP needs that because then it knows when you're finished typing, when, it knows this is one of the commands you sent, and there it ends, and there's another command. So yeah. So you need that. It's kind of like a string ending character kind of a thing.
Got it. Okay. Thank you also for telling us that, because it would have been very confusing. Especially because Arduino is probably one of the least annoying ways of using this. Because let me just give a quick example. I'm going to exit from this, not Arduino altogether, just from the serial monitor. I'm going to open a terminal window.
Yeah, please
and then
try
I'm
that.
going to type ls/dev/su. I can see it's connected here. So I'll type screen, the serial port it's connected to, and 115200. So again, my only objection is that it's not green. So I don't feel serious using it right. So here we go. Okay, yeah, it seems to work. I'll type help. For now, we can still look at the features through the Arduino serial. But yeah, it looks like upon testing, start, help, chicken. Nope, none of the critical functions worked, but that's okay. I'm gonna go ahead and
we will debug that later.
Yeah. So back in Arduino, and specifically back in the serial monitor for Arduino, wherever that went. Oh, nowhere, because I closed it. There we go.
Yeah, so there are a lot of commands. If you type help, there's a huge list.
Right. So one thing that I'm kind of giving people that have done a little bit of Wi-Fi hacking an analogy for to understand this is it's almost like a programmable or like a customizable or an addressable wireless network adapter that rather than needing like a Linux computer to like tell the wireless network to do all this stuff, you're kind of just telling it this wireless card directly, hey, pretend to be these networks that I say, or hey, scan these specific channels I'm specifying. Usually you need something like AirCrack NG controlling the wireless network adapter, which already costs like 5 times what an ESP does. But you have actually written code now that allows you to, with these command line functions, directly address the chip and tell it to do these things without any extra overhead on the computer, because you're just instructing the chip on what to do.
Yes, that's the great advantage. The chip is super cheap, and you can address the hardware much more directly than you could do over Linux.
Wow. Okay, so this is really cool. We have the first one is the scan command. So that seems to give you the ability to define the mode, whether it's looking for APs or stations, the time, so how long you're actually running the scan for, which channel you're actually going to run the scan on. So wow, there's lots of them, all the way up to 14. What is the CT or auto?
Don't you see the under the scan, you should see an explanation for each.
Channel scan time in milliseconds.
Yeah.
So that's how much time you're spending on each channel?
Yes, exactly.
All right, so that's if you're scanning all of them, or if you've provided a list.
Yeah.
So just to be very clear, you're dedicating a certain amount of time per second to that channel.
Yes.
Okay, cool. Silent mode, and then keep previous scan results. Cool. Where does it save the results to? So when it says keep previous scan results, then where does it go? Or like how would I access that?
Well, there is think of like an array where all the data is stored on the device. So if you disconnect it and power it up again, the scan list is gone, so it's just temporary. But if you also run a new scan, then you will clean that list. You can add this little -r. It's basically to tell the scan command like, hey, I want to scan again, but please keep the previous results. So don't delete them all.
Got it. Okay. So if you're like comparing something, you'd still be able to like compare the two scan results.
I mean, it adds it scans again, and everything it founds that isn't in the list will be added.
Oh, right. Okay. Got it. So then I also see that you added something that I requested, which is the RSSI meter, or the signal strength meter, which is really useful and cool for fox hunting. Can you explain what that does and what it's useful for?
Yeah, so we can have a look at that in a bit. It's very experimental right now. But basically, you keep scanning for a specific MAC address. So if a specific device with that MAC address sends packets, the ESP, gets that packet and basically tells you the signal strength of that packet. So it gives you this little, it draws, that's the goal at least, to draw a little graph or some kind of visualization of how close you are to that device. Because you get the signal strength, you kind of know how far away you are from that device just by looking at the packet's signal strength. And that way you can try to track down a specific device. Because, you try to get closer, then the signal strength gets higher. And if you have a directional antenna, then you could do something like fox hunting, where you try to find a specific network device nearby.
And you can also take one of the D1 minis that has the antenna that you can basically put on a directional antenna and basically use that as a direct signal strength meter and basically move it around and be able to pinpoint the exact direction that a signal might be coming from too.
Yep.
Cool. So then we have the results list, so you can see all the results of the scan, which is extremely useful. The beacon feature, which is sending out fake networks. And it looks like you also added the option to, oh my God, that's so cool, to define the type of encryption, which means you can fake encrypted networks as well as open networks, which is awesome. Silent mode, and then scan for authentications. So what is scan for authentications? Because that's one I've never seen before.
Yeah, that's one of the things we talked about earlier, one of the new features. You can start this beacon attack and create a bunch of networks that aren't actually there. And simultaneously listen for authentication requests. So if a device tries to connect to that fake network you just set up, then you will see which MAC address did that.
That's so cool. Okay, so you can start to see who is attempting to go after maybe like fake networks?
Yes, exactly.
Okay, that's great. I love it. So this is turning into kind of a signals intelligence tool. That's really cool. You can start to infer relationships just by analyzing the radio traffic with this tool.
Another thing I want to point out real quick, because I don't think I added this in the last version. You can specify with the to parameter where you want to send the beacons to. So by default, this is a broadcast. So you create these fake networks and everyone can see them. But if you just want to target a specific person and their device's MAC address, then you can create these fake networks and make them appear only to that device because you're sending the packets only to that MAC address. So that's also pretty cool.
Got it. All right, cool. Of course, we have the Deauther, which is where the main action is. And there's lots, it looks like even more ways of controlling the amount of packets per second, the packet types, whether you're sending deauth, disassociation, or both. So it kind of like makes it like a tool like MDK4? Whichever.
MDK3?
But just MDK3, sure.
I don't know.
The one that sends a mix of both deauthentication and disassociation. See, and then probe. So we have probe is sending probe requests, and probe requests have always been difficult for me to explain to people. What's your take on them?
Basically what I explained earlier, that your device, if you have no networks in your list and for example, your phone then tries looking for that Starbucks Wi-Fi you connected to a year ago or whatever, and it sends out these requests for everyone to see that is sniffing basically. Your phone is trying to, I feel like my explanation is shitty. Let me restart.
Well, the way I've described it is like if there's a phone out there that's trying to connect to a network it's connected to before, any attacker can listen in on that information and create a fake network that's designed to basically trick your device into joining it. So one thing I've done is if you want to unmask hackers in the area that are trying to do that sort of thing, especially like Hack5 equipment does this by default, you can just pop up fake attempts to probe a network that's not there, and then any hacking equipment nearby that's automatically reacting to it will just pop up that network and be like, oh, here it is, and you'll know that someone's out there trying to intercept your Wi-Fi. So it's kind of a hacking back technique that I think is kind of cool to be able to use that. And then actually, let's go ahead and get to this after this one, but alias would be the last one I saw that's really new. that's so that you can actually start to manage different MAC addresses without needing to constantly type them in, right?
Yeah, if you have a known device, then you can give it an alias, the MAC address of that device. So, for example, you could give the MAC address of your home network router an alias. So basically, you give the MAC address a name, and then you can use all the other commands that we just went through, where you could enter a MAC address directly. Instead of typing that MAC address all the time, you would just type that alias. So it makes it much easier to, type all the commands and yeah. Also for scanning, if you have an alias saved for a known device, like for example your friend's, I don't know, phone, and then you scan, and then you could directly see that name, that alias appear in the scan results list. So you would immediately know, this is that device. I have already seen that before, without keeping the entire MAC address in your head.
So I just went ahead and for all the beautiful options, the most simple command seems to be just to type scan. And it goes ahead and runs a pretty effective scan that continuously looks for both the access points in the area and then also the devices, and then very plainly tells you which is connected to which. So I can see right now that there's 2 different devices that are connected to the cellular network we set up, and there's another device nearby that's set up and connected to the satellite connection we have, which is terrible. So if I wanted to then select and start watching, or alias, I guess, let's say the cell phone that's connected to our satellite internet, it would be ID number 1, and it's a station, it's a client. How would I alias that so that I can track that?
You don't even need the ID. Just type alias, add, and then copy paste the MAC address.
So alias and then
alias space add space, then the MAC address, then another space, and then the name you want to give it.
Okay, and you're saying at AT? I should just scroll up, but yeah, let's see. Alias.
Alias add.
Add. ADD. Sorry,
yeah.
Alias add, and then the MAC address, and then the name?
Yeah.
All right, let's try it. Alias add, some MAC address, and then dingus.
And then if you type results, you should see the result list again.
Cool. And cool. So now I can see the dingus is connected to our satellite internet.
Great, yeah.
All right. So what other ways could I use the alias feature? Like if I want to look at let's say that I want to start tracking dingus. Can I use let's see, I'm just going to type help again. But can I use the RSSI feature? Sorry to just jump into it, but that's the one I'm most excited about.
I know. I would say I'm not sure, because this is super experimental. It's kind of shitty. It's not fully implemented yet. But go ahead and try, because I'm not sure if I edit
So RSSI dingus?
Yeah.
Okay. Is it case sensitive? I guess I'm going to find out. I'm just going to stop asking questions and it works. It works. Okay, cool.
Really?
So, I mean, it's just output. It's not doing graphic anything. It's just showing me, the current RSSI, but it's showing it quite frequently. So I can
a lot of packets,
I can see that there's a lot of packets. So I'm just going to ask my production person who has which phone is this? I think it's a Samsung phone. Well, I was going to ask them to walk out of the room and walk back in, but I'm not sure if that would even work. Let's see.
The thing is, if you're trying to track a station, so like a client device, like a phone, that only works really well if that phone constantly sends data.
Right, which it looks like it's doing.
That's good.
Let's see.
Also, keep in mind, this is all 2.4 gigahertz Wi-Fi, because the ESP can only do that. So maybe if you're trying to track something that is connected over 5 gigahertz, then that wouldn't work.
Okay. So, I'm seeing the signal change a bit as the person with the phone walks around a little bit. So this is a way that, especially with the directional antenna, I can basically see exactly the raw signal strength and maybe start interpreting that in a graphic interface or something like that if I wanted to take this to the next level. But this is a really encouraging start. I can just specify any device that I see and then just start monitoring its signal strength to see first if it's in range and then, what the signal strength is if it is in range and get a feeling of how close it is to the receiver.
And I just want to say again,
So how do I...
this is implemented just today. I'm going to make this way more fancy so you can actually use it and not just have a bunch of integers printed on the screen.
So all right, so far we've done a scan, we've detected a device, we've aliased it, and now we've done a signal meter on it and basically watched it to see what the signal strength on it was.
Yep. You want to deauth it next?
Yeah, let's attack it. So doing the deauther, just using this, I would just write, let's see, deauth, and then station ID to attack. Do I need to...
You can... Oh, it's a station you want to attack, right? So then you just do deauth -st and then the ID. That's the easiest way.
Thank you. Deauth st dingus. Send.
Oh, not dingus. Then you have to put in the ID. Sorry. Because dingus is just an alias for the MAC address.
Oh, so I need to
put in the ID.
So that's where I do need the ID.
Yep.
When I type in results, though, they're gone. Should I do another scan?
Oh, they're gone? Have you...
Yeah, they're gone.
Why is that? Mine are not gone. Have you done another scan?
I did try to deauth dingus, and it crashed.
Oh.
And restarted.
Deauth dingus. That doesn't crash for me.
Deauth-st dingus.
No target specified. Huh. Did you find the bug?
Maybe it tried to... I think I did. But I just ran another scan, so now I should have results, and now I should be able to deauth the station when it's done.
While you're doing this, I should mention that if you are showing any of my screen that I'm recording right now, I have a modified version. So before we started recording, I just quickly added some changes that all the MAC addresses you're seeing on my screen are not actually real, and the SSIDs and all that stuff is cut off. So it makes it much harder for people to track me down. I'm not saying it's impossible, but
I see that the dingus alias is still added on this.
Oh yeah, those are
persistent?
Yes, persistent. Thank you.
Cool. I also see that there's an Apple device that is connected to the satellite internet. So I'm just going to select station 0. And then, so deauth st0 would be attacking station 0 in this list. And I get a big fat crash. Deauthing and disassociating target, transmitter, blah, 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 11. It says PACKE, and then it crashes. Exception 9, and we get a big old crash.
Oof, this is not good. Oh.
Yeah. Did you get it too?
No. I just get no target specified. That's weird. Dang it. The most important feature isn't working right now. That's not good. That's not good. Yeah, why is that not working?
So we leveled up on the signals interpretation, but we're still trying to figure out the the main functionality. So then, yeah, after the crash, it looks like there's no targets anymore. So I have to, after it crashes, it clears the memory.
Can you copy the log that you get after the crash and send it to me?
Yeah. Once this finishes scanning.
Because I might be able to exception decode. Although, I can try anyway. Even though the code I'm running currently is a different. It's modified a bit. So I'm not sure if the exception decoder will work here, but.
In the chat, I have dropped the error. Oh wait, it won't paste. It just complains at me.
How do I see the chat? There.
Well, there's nothing in it yet. Oh, okay. Well, either Arduino refuses to give up the goods on.
Whatever. One thing
Here,
that definitely
I'm gonna
works-
share my screen.
Okay.
Stop sharing your screen for a second. I'll share mine.
One thing we can show is the beacon command that works, at least on my end.
All right. So this is what I'm seeing on my end.
Yeah.
A big.
And you cannot copy that?
No, this is apparently impossible to copy.
Why?
I have tried. I don't know. See, I can't right mouse click on it.
No,
It's just,
but
you
like
know.
Control C or CMD.
Yeah. Oh yeah. No, I've tried that too. Command C. Try to paste it. Oh no, it does do something, but then it actually won't paste. It won't paste in the Zoom window. I don't know. It's a mystery of science.
Put it in Discord. Also copy not just this. Whatever. Just send it to me some way or another.
That's awful. Here.
Sorry. Sorry for writing crashing software.
Oh no, not that. I was referring to the state of my Discord.
A lot of people have. Why am I so? Yeah. I was going to complain why I'm like not in the top of your list there.
Oh yeah, no. Well, I mean, you don't need to feel bad because Discord apparently doesn't even work.
Oof. Yeah, come.
Yep, it's frozen.
We can just ignore this and go on.
Yeah. Let's just move on. Okay, so for now that feature is not working, but I'll stop my screen sharing and maybe you can walk me through another one.
Okay. Share screen. Okay. So we could try a beacon attack. So you can just type beacon and actually let me try out if this works. Oh yeah, great. Okay, so you just type beacon and then whatever SSID you want to create. So I don't know, hello world, and then enter, and it would create that that SSID. If you want to create multiple ones, then you can just do that. I don't know, 1, 2, 3. Does it work? Yes, perfect. Yeah, you just write down the different SSIDs and separate them by commas, and that's it. And then if you're scanning on your phone or, I don't know, laptop, whatever, you should see these networks appear. Sometimes it takes a bit. And if you try to connect to them, I think my version doesn't show it because I removed that so it doesn't leak my MAC address.
But in theory, if a device tries to connect, it should tell you. Does it tell you which device it's connecting to? Or which fake network it does?
Yes. Try it on your end. Should definitely work.
All right.
If not, I'm gonna be very disappointed.
Okay, I'm gonna attempt to connect to one of the fake networks. Let's see if it works.
Shit, that was my Marta button.
Let's see, it looks like my device can see it, but when I try to connect to it, I don't see anything.
Oh, that's disappointing.
Let's see. I'll also stop. Let me just try one network rather than trying to do two. Do the beacon networks need to be surrounded by quotes?
Only if they have spaces in them.
Okay. Okay, I'm creating a network. No. I'm trying to connect to it, and of course it can't because the network's not real, but it's not showing the authentication packets from it.
Dang.
Maybe I should try the authentication.
Oh, sorry. Yes, if you do it, you have to type beacon, then whatever SSID, and then -scan at the end.
Oh,
I'm sorry.
Okay, let's try it.
It's optional. It's not by default. I had it set to do that by default. I changed it just yesterday or something, so that's why I forgot.
Okay, all right. So I think I created the network again. Beacon, big faker, pack S. And now I'm trying to connect to it. And it's just -S to scan, right?
-scan.
Oh, -scan.
-scan. Oh yeah, -S is for silent, so it won't print anything.
That's why there's no output. I was like, wow, it's working so well. -scan, all lowercase.
Yeah.
Okay.
It should tell you that it's also scanning for authentications if you do that.
Scanning for authentications. Yes,
Perfect.
It does. Okay, cool. I see the new network I created. Hey, okay, cool. I see. Interesting. Oh, it's actually okay. It's finding probes for other networks.
Nice. That's really good.
So I can see. Yeah, so I can see like I can see other networks that there's just an AN C5 Wi-Fi network. So we have small faker is the one that a device is trying to connect to, and I can see the MAC address. I can see other probes. All this is super interesting. Okay, so my device has tried to stop trying, but if I were to tap on it again and try to force it to try again, I imagine I'd see another spike of packets trying to authenticate. Wow, well that's pretty cool. Okay, and now it's giving up lots of information because I can see all the stations in the area that are trying to connect to networks. So if I press stop,
then type results.
And then results. Let's see. Access points. Okay.
On the right, you should
And
see
we
the
can
probe
see-
requests.
Oh, that's super cool. Okay. So,
That's what probe requests are. We can explain it visually now.
yeah, so we see, so just looking at the information I can see the number of packets, so we can see how actively that device was seeking that MAC address, or how many packets we totally intercepted. We can see the MAC address of the device that was doing the requesting. We can see the access point BSSID or the network that it was connecting to. Is that right?
Mm-hmm.
Access point SSID
Well,
and probe requests.
The access point SSID and access point BSSID you will see in that list is the one that device is connected to currently, or was connected to the last time it saw it.
Got it. So, for example, the next one on my list is showing that there's no access point SSID, but it is showing a probe request. So that means that it's currently not connected and sending out probe requests for a network that it's not currently connected to. Okay, cool. So this is then showing the behavior of individual devices on a pretty granular level. It's not only showing the devices that it's looking for, it's also showing the devices that it's currently connected to, just so we get an inference of the relationship between those two. That's pretty awesome. Let's see. Cool. Well, that one worked perfectly.
Yeah, that's a great feature, I think. And there's a bunch of things here that can be done over the CLI. All the commands we used so far are very, we only scratch the surface here, because you can send beacons to a specific MAC address only, so no one else will see what you're trying to do there. You can specify the channel, how long the attack should go, all this kind of stuff. You can specify a MAC address that the beacons should come from. So basically, you could try to pretend to be a certain network, not only by copying the SSID, but also copying its MAC address. So you would really appear to be that exact network.
Wait. Okay, using this, could I copy the MAC address of an existing network and then create, 100 clones of the same SSID, so it's basically impossible for my phone to know which one's real?
You can. The only problem with copying the SSID is if it's the same SSID you're sending out, even from different MAC addresses, your phone or whatever you're scanning with will only will show that only once, because every SSID it gets that's exactly the same, it will kind of merge that. That's how mesh networks work also. But if you, add spaces or stuff like that, that wouldn't, so that the string, the SSID string is actually different, but for a human looks exactly the same, then yeah, you can do exactly that.
Well, I was thinking even just if I tap on that, if there's 100 fake networks and one real one, even if they're all listed as one network, when I try to join it, how would my phone have any idea of knowing which one was the real one if they all have the exact same MAC address?
You are right. Yeah.
Let's do it. Let's test it.
I have not thought of that yet.
I kind of wondered about this as like an alternative form of jamming, but now that it's so much easier to run these commands, let's try it. So I have my MoFi network that I'm going to be attacking. So I can see that that's station 0. If I wanted to effectively clone station 0 100 times and then clone its MAC address too, what's the simplest command to do that?
I mean, 100 times. What do you mean by 100 times? Because 100 times would mean you create 100 different SSIDs.
Yeah. Well, yeah. Well, I was thinking put out as many packets that are from like a seemingly the same source, but then make it confusing to know like which. Well, let's try it. How many? I mean, should I just do one, or I guess they all are identical.
I think you only can do one. Once. I know that I wrote it down to my to-do list right now to add a parameter so you can change the packet rate for the beacon command. Right now that's not possible, cool. So it only sends 10 packets per second. So I think for our example here, you just put in the exact SSID and the exact MAC address, and that's it. Also the channel. Don't forget the channel.
So that would be beacon.
Mm-hmm.
And then, the channel too. So it would need to be, it's on channel, where's the channel? Oh, here it is. Channel 1. And copy this. Beacon. So is that dash, let's see. I'll just look it up. CH1. SSID from. Whoa! Oh my god! It just dropped so much unnecessary. It just dropped the copy and paste from the crash. Man, Arduino really sucks at allowing me to copy and paste information effectively. Oh my god. So we'll go ahead and take this.
I think I want to. Another thing I'm going to add is something like beacon clone, and then you just give it the ID of an access point you already scanned for, and then it would do exactly what you're doing now, but automatically.
Okay. So currently it's on beacons, channel 1, the SSID is specified, and then the from is specified. Do I need to add anything else?
I don't think so, no.
Okay, let's
maybe
try it.
The encryption, if that's...
Oh, yeah.
That's maybe...
Yeah, that's a good idea.
Yeah.
ENC WPA2. Does it like it? Okay, yeah, it likes it. So now I'm gonna.
Did you add dash scan as well?
Oh no, I didn't. I'll stop. And then dash scan. Oops. And then dash scan at the end. Okay, here we go. All right. So now I'm checking on my cell phone. I'm currently connected to some other network, and I see the network that I want to connect to. It looks like so far it only sees it as one network. So if I attempt to join it, well, it instantly connected correctly. So that kind of busts our theory about being able to confuse it by offering a bunch of other ones. But if we did specify the MAC address, then that could become confusing just by having a bunch of different options. So I was thinking that the phone would just go through different options and maybe get confused. But if we're just spoofing, like literally just basically handing out even more beacon frames that are all advertising the same MAC address, then there's not really too much confusion between the devices as to like where the packets are supposed to go. We're not intercepting the packets. We're just like putting out more packets pretending to be the router. So overall, not too much of an effect, but we can see every time. We're basically then monitoring that frequency. So we're ensuring that any device that tries to join the network, we log it. But the difference is instead of it failing, it actually works because, we're just watching a legitimate network. Although at that point, I guess the beacons are a little superfluous.
I already made 5 notes on my to-do list just since we started discussing the beacon command. There's a lot I can add here. I think this is great.
Cool.
Thanks for the input. By the way...
of course. Well...
Sorry.
No, after you.
You went through all the trouble of typing down that really long beacon command. There's an easier way now. Just, if you stop the attack, just type in start. And then some nice assistant will guide you through the steps.
Oh, that's so helpful. Good morning, friend. What if I do this at night?
It's still good morning.
I guess it's morning somewhere.
Yeah.
What can I do for you today? Oh, it's so polite. Scan, beacon, Deauther, probe, alias, results. Love it. That's great. That's great. So you have a little walkthrough as well. So anyone who's maybe following along that feels a little bit overwhelmed could also get started with this by just getting up to this point and then just being kind of walked through by the start command.
Yep. So for example, we could just go through the beacon command again and just show how more convenient it is to go this way. So yeah, if you're in the process, then just type beacon to go to the next step.
See.
Does it work?
Let me stop. We'll do beacon. For which names do you want to advertise? Big nets. What is the address? Random.
Oh yeah, so you can see
who is the receiver?
It says default random. So if you just press enter, it will take the default. So you don't actually have to type, for example, broadcast if that's the default anyway.
Oh, so you can just default it.
Yeah, just press enter and it takes the default one. So like an empty line. Like don't type anything, press enter. It will take the default option automatically.
Oh, okay. That's fine. Oh, wait, in the default option, who is the receiver MAC address? For example, there's 3 characters in the last slot for the MAC address.
Oh, okay, just I'm writing it down.
While we're while we're bug fixing.
Good that you say that. Yeah, this looks like a copy paste error, because the who is the transmitter sender, it has the same MAC address, but that one is correct.
Then what encryption should it use? Open on WPA2. I'll do open. What channel should be used? 6. How long should the attack last? 0 for infinite. Enable silent mode? Nope. Scan for authentication request? Yep. Oh, wow. Okay, so this is a completely basically interactive way of constructing these commands for people who know what they want to do but don't know what the right command is yet. It asks you about all the options, and it's kind of like, I don't know, like making your own pizza. It just asks you about all the toppings, you decide what you want on it, and then you send it off, and here it goes. So now I can see, if I scan on my phone, can I see this network? Yes, I can. Cool.
Yeah, the great thing is it goes through through the process step by step, and at the end it prints down the entire command you need to do the same stuff again. So you could, that way you can learn about the commands and how they are structured, and also just save commands if you're frequently using them. But yeah, it makes the entry more convenient, I would say.
Okay, well, I got disconnected for a minute, but What we were last looking at was some of the final improvements we were going over, such as the beacon requests and being able to use them flexibly to create pretty much any network we want and affect the devices around us, as well as scan for what those devices are doing when we send out those requests. So overall, this is a lot of new stuff. And while we did get rid of the whole web interface, and it looks like the deauth feature might need a little bit of polishing, overall, some of the things that we've added are much more now more about kind of signals intelligence almost, or being able to monitor the behavior of devices around you rather than explicitly interacting with them first. You're able to first scan, select them, and then individually single out one and kind of either monitor it or start presenting it with fake networks and otherwise kind of start, I don't know, kind of targeting individual devices rather than just attacking everything at large or just scanning everything at large.
Yep. And the web interface, I'm going to add it, but it's probably going to be way less powerful because all these features we looked at now are things you can only do while the access point is off, because you are going to need that to scan and do all that stuff. But it doesn't mean the access point is gone. But I mean, this tool becomes much more powerful now just through that command line interface. So yeah, that's the whole new big feature, the entire improved interface here. And
super cool. Like so yeah, let's definitely follow this. And as we add more features and as I keep recommending stuff, I would love to be able to maybe make this more regular and just keep popping up with new bad Wi-Fi stuff we can do every once in a while with this cool project. In particular, if there's I guess the best way for people to follow this project would be the GitHub or Twitter, or what would you recommend?
Well, you can go to the GitHub repository and watch that, follow that, star it, whatever. But you can also follow me on Twitter. This is @Spacehuhn. And that should be sufficient enough, I guess. You can also follow Cody, in case we make another of these episodes.
Oh yeah, because I always retweet updates to the Deauther project because it is among my favorite projects because it is cheap, effective, and cool.
Yep, and I have a lot of features on my list still. A lot of like simple stuff and more advanced stuff, bug fixes. We haven't even looked at all the things that it can do right now. So yeah, I think that's cool if we make more of these kind of episodes here.
Yeah, cool. Well, thanks for walking us through all the updates to the Deauther project and also bug fixing with us as we go through and set it up. Really, all you need to follow along on this is some sort of ESP8266 board, preferably a Wi-Fi network you have permission to attack, and a computer that can connect over serial so you can run Arduino, upload the sketch, and then just get started playing with Wi-Fi hacking.
Yep. Thanks for going through this with me, because now I have a much longer to-do list with a lot of things I can probably fix easily. So I'm gonna have to do something for tomorrow. And yeah, that was fun.
Yeah. So if you like this, big thanks to Veronis for making sure we can do these live streams and workshops and go through all these interesting tools. If you want to support us, we're going to try to put some extra links and resources, either with the link here, we'll tweet it out, and you can go ahead and sign up to know when we're going to go live and do these workshops, when we're going to be like putting out these little live events. And you can also support us by, letting us prove that people are interested in this sort of stuff and reach out to you whenever we have something really exciting and new coming up. So you'll get access to hopefully some links to the stuff that we talked about today, maybe some suggestions on hardware where you can pick the stuff up. And also you will be supporting us, being able to have interesting people do these with us and show off their great projects. So lots of bugs, which is kind of what we're looking for nowadays, as we want to cover bleeding edge stuff that may or may not work, figure out why it does or doesn't work while we're on air, and rather than assuming everything's going to go perfect, just kind of have some fun. So thanks for hanging out with us today, Stefan, and I'm sure we'll see the Deauther or the Wi-Fi Ducky or another one of your projects very soon.
Oh yeah, looking forward to it. Thanks for having me, and yeah, that was fun.
Anytime. All right, see ya.
Bye bye.